Hello, we are from COE119L, Computer System Organization with Assembly Language, Section E02. I'm Raphael Ansino.
I'm Errol.
I'm Edison Boris.
So we are here to discuss the design of experiment.
And our design of experiment is all about two fuse.
So this is the two fuse game.
Two Fuse is a fast and furious arcade-style game which pits players against the clock to match and fuse as many similar icons as they possibly can within 60 seconds.
For our statement of the problem, the group should develop successfully the proposed game by applying the acquired knowledge of assembly programming used in the laboratory drills and all concepts imparted in a class lecture.
The objectives in our design of experiment is to apply the concepts learned in computer system organization with assembly language and to implement that game to fuse in assembly language.
So we will demonstrate the game to you now.
Explanation.
So two fuse is played when we combine two panels together with the same color and same number in it. We will have a score of 1 if we combine the panels which has the number 1, and a score of 2 when we combine two blocks with number 2. As you can see in the my score, we have plus 2 points, and we will have a score of plus 4 in our current score if we combine two stars like this one. As you can see there, the score incremented by 5.
So as you can see, you can combine different color of panels and different numbers.
And after the time ends, then it will print the my score there. And if it is higher than the high score, it will go to this text file called HS2 fuse. And it will be saved.
For the scope and limitations of our program, interrupt 10H, interrupt 33H, interrupt 1AH, and interrupt 21H are used in this program.
Mouse is only used in this program.
File handling limited to text only.
And for the explanation of our codes,
Hello. As you can see here, this is a two-fuse game running by DOS. Then you'll see here, they printed my score and I printed high score. And if the my score is greater than the high score, then it will save in the text file called HS here, HS2 fuse.txt. Then let's play. Wait. And the goal is you need to pair a same number with the same color. Then if you just 1 and 1 and red, then you'll see it will change my score from 0 to 1. Then if you pair a number 2, it will increment it by 2. And so on and so on. And here, as you can see, this is the time limit for this game. We are given 60 seconds to finish the game, and let's wait until the time goes 0. 8, 7, 6, 5, 4, 3, 2, 1. Then when it will appear the game over menu, which is the time is up, and then as you can see there is two options, play again or exit. If you choose the exit, the program will exit. Then if you play again, of course it will play again. And here is the ASM file of this code here. So in this here, the highlighted code here is the constants video constant values, your digit palette port, color selection port, palette index, background, set video mode, get video mode, video segment, input keystrokes, and the mode 13. Here, there, and this is the data segments, start of the data segment, and these are the coordinate values, the variables for a graphic user interface coordinates. There. This is the code here. Then it will output, and this is the output of this code. Then let's proceed. And in this panel, it will generate a random variables, like I said. Wait, let's play it again. Yeah, if I choose 1 and 1, then as you can see here, it generates a random number and a random color, and this is the code for that. And then in this section, this is responsible for file handling variables for the file handling, file name, etc. etc. Right. And wait. And this is the responsible, like I said earlier, that if my score is greater than the high score, then it will automatically save in E02's text file. Then, and even if you exit the game, the high score will remain, because there's a text file called E02, and it will print out the latest high score. And here, this long column is responsible for a graphic user interface sprites variables for a GUI sprites or graphic user interface sprites, and each byte represent a one color pixel here. These colors, and yeah, and this is so in code segment, we start of code segment, and here is the main procedure of the program. Main procedure or start of the program, main prompt, begin of AX data, and so on and so on. And this section, this is to initialize game's procedure. Procedure that initializes game variables to initial values and set video mode, screen background, and start preparing. Like here, so the initialize game clock of as move random red, move random green, so on and so on. And in this section, the setting the video mode. It saves the current video mode, switches to a new mode, and point ES to the video segment. This is the code for that. And the set video mode prop PH, set video mode, and so on and so on. And for the setting of the screen background, here the settings here. It sets The screen background color, video palette, index 0 is the background color. And this is the code for that. It sets screen background proc and comment with video palette port, which is in hex 3CH, C8H. The color selection port, which is 3C9H. The palette index background is 0. Set video mode 0, 0, and video segment is 0A000. Wait for keystroke 10H. Mode 13, 30H, and so on here. Then in printing the pixel, the change printed cell color in particular coordinate. Also, this is the video memory location. Here, if you print pixel proc push A move X 320 and so on. Coordinate of the screen pic. And in this section, oops, so in this section, the generating the game background procedure. This is to generate a game background. The code for generating a game background here, here, and for the countdown line procedure, this time, as you see earlier. Wait, let's do it again. And wait, and then there. This is the countdown line procedure. Generate timer line and decrements it every second until time's up. And this code for that. Timer proc pushing. Move X or 219. This is the coordinate here. Okay. And so on. And in particular box color here, right here. Let's play it again. Wait. As we play, it generates a random color in a particular box, and this code, the highlighted code here, is responsible for that. Click background proc. If you click, then push A, move AX, X team, move X core. This is the coordinate, of course, and so on and so on. Then in the and here in the panel here, the game over mouse procedure, the procedure that initializes game over mouse. Of course, if the time runs out, it will generate a text box here. Wait, let's wait. 5, 4, 3, 2, 1, and here we go. This is the game over mouse procedure here.
Hello, I'm Raphael Ansino, and I will discuss the following procedures. First is the time equal to 0 procedure. When our timer hits 0, this is the procedure that will determine it. It is determined by the interrupt 10H for times up 1 and 2, and a small window here will be shown which says time is up, and play again and exit buttons are available. When we click the play again button, we will be prompted here, which is the procedure for play again, where it has interrupt 10H again, where it will prompt the program to restart from the beginning where the time will be restarted from 0 to 60 seconds, and my score will begin from 0 again. And we also have the exit button here, which is connected to the exit procedure, which will exit the program, and the end of game procedure here, which is connected to the exit procedure, where, what I've said, will exit the program. Next is the drawing sprite procedure. What is a sprite? A sprite is a bitmap graphic that is designed to be a part of a larger scene. It can either be a static image or an animated graphic. As what I've said, this is the procedure where the colors of the tiles is determined, whether it is a red pixel, a green pixel, or a blue pixel. Next up is the initializing names procedure, where the time name procedure is the time name to procedure, which is this one, the high score name, this one, and the high score name 2 here, the numbers here, and the my score, this text, and the my score 2, which is as you can see here, the 3 zeros, which will be added while the score goes up, and the and initialize names, which is inside this small square. It all have an interrupt 10H code. The interrupt 10H is for video processes. Next is the procedure for time displaying, which is here. It starts from 60 seconds up to 0 seconds, which is a -1 per second time, which from the beginning of the program starts right away. It also has an interrupt 10H for video recording, as we can see here. It's graphic, and it loops the display time over time from 60 seconds to 0 seconds. If like what I've said, if the timer reaches 0, it will call the game over procedure and display time procedure, that the time is up. Next is the procedure for updating time. It has an interrupt 1H code, which is for time, which decrements it from 60 to 0. The tick is 1 second every time. And next we have the box dimension coordinates for our program. This is where we move it. We move the one tile to another, a one tile to another, and a one tile to another. It have coordinate 11, coordinate 12, coordinate 13, coordinate 14, coordinate 21, coordinate 22, coordinate 23, coordinate 24, coordinate 31, coordinate 32, 33, 34, 41, 42, 43, 44. Get a random number proc procedure is where we also use an interrupt 1H, where every time we add two squares, the square where we first click our mouse gets a random color, but a number of 1 will be preceded by it. Here we can see the random color. It initializes a loop where every time we click the first box we click, we'll get a random color, whether it's green, blue, or red. As we can see here, it has different colors in each of the 16 tiles. As we can see here, it just keeps on looping and looping every time. And the end game here is where the time reaches 0, it will prompt it to stop looping.
So for mouse interaction procedure, it
this is the procedure for main game mouse to interrupt, just like this. Mouse int proc, push ES, push A, call get high score, move AX0H. So the int 33H is to just show the mouse. Move AX1H. Int 33H is to get mouse place and status, just like this. Move AX07, move CX5, move DX635 is the horizontal limits of a mouse. Int 33H, move AX08, move CX2, move DX198 is the vertical limits of a mouse. Int 33H, move AX04H, move CX200, move DX100, int 33H. And to reset the mouse, we have move AX03, int 33H, move mouse button DX, move mouse row DX, move mouse column CX, CMP mouse row 52, JB mouse loop, CMP mouse call 184, JB mouse loop, CMP mouse row 187, JA mouse loop, CMP mouse call 454, JA mouse loop, CMP mouse row 82, JB mouse core 11. Mouse core 11, CMP mouse call 244, JA mouse core 12, test mouse button 1, JNEM COORL 11, test mouse button 2, JNM COOR 11, test mouse button 4, JNE MCOR 11, GMP mouse loop. For mouse core 12, CMP mouse call 254, GB mouse loop, CMP mouse call 314, JA mouse core 13, test mouse button 1, JNE MCOOR 12, test mouse button 2, JNEM COR 12. So the mouse score 11 means the number of horizontal and vertical lines. So we have four horizontal and 4 vertical. So the screen was about 4x4. Mouse loop, call update score, call update time, call display time, GMP reset mouse. The MCOOR11, move AX2H, int 33H, call core 11, move box BG color, which is color of the box, and call click BG, call box BG checker, proceed. So if you touch the same panel, it will proceed. And then move AX1H, int 33H, call CMP high score to my score, call update score, call change high score, call update time, call display time, call delaying, GMP mouse loop. So this segment is to call or read the program. So we have 4x4 dimensions. So
every dimensions has the same codes. Game over mouse procedure. It proceeds for game over mouse to interrupt. So the code will be mouse game over proc, push ES, push A, mob AX0H. So if the in33H just to show the mouse, mob AX1H, in33H, get mouse place and status, mob AX07, mob CX5, mob DX635, horizontal limits, which is the horizontal limits, in33H, mob AX08, mob CX2. So the mob DX198 is for the vertical limits of the mouse. In33H, mob AX04H, mob CX200, mob DX100, and in33H. So it was this. The game mouse procedure is almost the same in the mouse introduction procedure, but it doesn't have mouse coordination for mouse loop. So the reset mouse game over, the code will be mob AX03, in33H, mob mouse button DX, mob mouse row DX, mob mouse call CX, CMP mouse row 120, GP mouse game over loop, CMP column 238, JB mouse game over loop, CMP mouse row 142, JA mouse game over loop, CMP mouse call 396, JA mouse game over loop, CMP mouse row 126, GBE play again, CMP mouse row 136, JAE exit now, GMP game over loop. So the play again is this. The code will be the play again is pop A, pop ES, and to call initialize game. So the game will start again. In the end mouse game over. So pop A, pop ES, call end game. So the game will end again. So it was the program was in the loop. We have if statement here. So check what box procedure. This procedure is for checking the box what is clicked. So from the it was the same the first program, the mouse interaction procedure. Push A, mob AXX dimension, the dimension of horizontal, and the mob BXY dim, the dimension of vertical, mob box checker 0 AL, mob box checker 1 BL, CMP box BG checker 00, JE init box checker proc. So the push A mob AXX dim, this is the dimension for horizontal, CMP box BG checker 0 AL, JN index box checker proc, mob AX for the Y dimension, for the vertical dimension, CMP box BG checker 1 AL, JN index box checker proc. So for check colors, the procedure for checking which box color click. So the program will be here.
Kita ka ba dyan?
So here is for the pair of ones, just like this in the game. Pair of ones. This is the code for pair of, and the pair of twos. Pair of twos here. That will be output a star and a pair of stars like this. That will reset. So we have a code for box that are not equal, just like this. So to get the high score procedure, so this is the code. This we can get the score in a text file, so we need to call or open the file, read it, and close it again. So for if your current score is higher than the high score, the text in the text file will overwritten by your current score, which is the higher than the previous high score. And this is the code. And this one's the that will compare the high score and my score. So this code will create a file for the score, and this one is to open the file, the high score, and this one is to read the file. And this in the write a file is when you exceeds the current high score, and this one is to close the high score file in the text file, and this one is to when something in the score has an error. We also have delay time program.